And so ngayon, try natin mag-solve ng mga practice problems for hydrodynamics. For this problem, sabi dito, a jet of water having a velocity of 25 meters per second strikes a curved vane which is moving with a velocity of 10 meters per second. The vane is symmetrical and is so shaped that the jet is deflected through 120 degrees. Find the angle of the jet at inlet of the vane so that there is no shock. What is the absolute velocity of the jet at outlet in magnitude and direction, and the work done per second per kilogram of water? Assume that the vane is smooth. Let's make a simple illustration ng ating problem. So, let us say this is our vane. Draw tayo ng construction line for our x and y axis. So, sabi sa problem, the jet is deflected through 120 degrees. So, ito yung sinasabi niyang 120 degrees. That is 120 degrees. Therefore, itong angle na to is also 120 degrees. And kung hatiin natin yung 120 degrees sa gitna with respect sa ating y-axis, angle of this one is 60 degrees. And ang angle na to, kung ito ay 60 degrees, angle na to ay 30 degrees. Because this is a right angle, so 90 degrees. 90 minus 60 is 30. So ngayon, if this is our point 1, ito yung ating mga velocities. So ito yung ating mga velocities at point 1. This is your V1. And this is your V prime. This is your U, which is the relative velocity. This is your V1 normal. And this is your Ux, which is the x component of our relative velocity. So, if this is 30 degrees, therefore, ang angle na to ay 30 degrees din. And if we are going to make a horizontal line here, yung angle na to is also 30 degrees. That is 30 degrees, therefore this is 60 degrees. So 60 degrees to, 60 degrees din ito syempre. This is a right angle. So ito yung angle na pinapahanap, which is yung angle ng velocity 1 para walang shock yung pagpasok niya dito sa ating vane. So if this is 30 degrees, therefore this is 150 degrees. Kasi 180, which is yung half revolution, minus your 30 degrees. So ito yung matitira, which is 150 degrees. Punta naman tayo ngayon sa point 2. Punta naman tayo ngayon sa point 2. This is point 2. So, if this is your relative velocity, so dito, yan. Therefore, ang labas nito is also your relative velocity. Now, if this is 60 degrees, therefore this is also 60 degrees. Therefore, this one is 30 degrees. Now, this one is your absolute velocity at point 2. And this is your V2 normal. And if this is your V2, therefore, ito yung iyong V2x. Yung x component ng ating velocity 2. And this one, this velocity is your V prime. So for this problem, ano ba yung mga pinapahanap? So, angle of the jet at inlet. So, ito yun. Angle of the jet at inlet. Degrees. Absolute velocity of the jet at outlet. Meaning to say, your V2. V2. In magnitude and direction. So, meron kang magnitude ng V2 in meter per second and the direction in terms of angle. Angle of V2 is equal to degrees. Work done per second per kilogram of water. So, work is equal to, say this is in kilowatt. So, first, let's try to solve for the angle of the jet at inlet. So, in order to solve for the angle of the jet at inlet, we need to use the sine law. So, for sine law, kailangan natin yung values ng velocity and value ng angle opposite to that velocity. What does that mean? So, kailangan natin yung V1. So, may V1 na tayo. So, V1 over yung opposite angle niya. So, opposite angle niya is 150 degrees. So, since this is sine law, we need to use the sine function. That is equal to our V prime over sine. Ano yung opposite niya? Yung opposite niya ay hindi 30 degree, pero ang opposite niya ay this angle. So, ano ba yung angle na to? Kung ito yung angle na pinapahanap, ito ay same sa angle na nandito. Ayan. And kung nandyan siya, 30 minus yung angle na yan ay yung angle na to. 30 minus angle na pinapahanap. So, 30 degrees minus yung angle na pinapahanap. And so, we can now solve for this one. So, sine 30 degrees minus, i-rearrange natin yung ating equation. Sine 150 degrees times V prime over our V1. And so, ito inakit natin dito, multiplied to V prime over the V1. So, ito inakit na lang natin dito. So, supplying the values for V prime and V1, V prime is 10 meters per second over V1 na 25 meters per second. So, magkakancel yung mga units na to. Therefore, yung angle na hinanap natin ay may value na 18.46 degrees. Now, we need to solve for V1x. So, yung V1x natin ay ito. That is your V1x. So, x component ng ating velocity 1. So, to solve for that, we can use yung value na ating V1 and the value ng angle na nahanap natin. So, V1x is equal to V1 cosine 18.46. V1x is equal to 25 meters per second cosine 18.46. Therefore, V1x is equal to 23.71 meters per second. So for V1n, that is equal to V1 sine 18.46. Therefore, V1n is equal to 25 meters per second sine 18.46 degrees. Therefore, V1n is equal to 7.92 meters per second. Now, we need to solve for our relative velocity. So, to solve for relative velocity, sine 30 degrees is equal to opposite, which is v1n over our relative velocity u. So rearranging this equation, we will arrive into v1n over sine 30 degrees. So we can now solve for the value of our u. Supplying the value for our v1n, that is 7.92 meters per second over sine 30 degrees. U, therefore, is 15.84 meters per second. So, nakuha na natin lahat ng kailangan natin at point 1. We can now go to point 2. So, sa point 2, since yung vein natin is smooth and therefore frictionless, yung ating U at point 1 is also the same sa U natin at point 2. Therefore, the value for our U is 15.84 din dito. And then the V prime is same as the V prime at point 1, which is 10 meters per second. Now, to solve for V2N, we can use the value of U and the value of our angle. So, V2N is equal to U sine 30. Paano nangyari yun? So, this is our hypotenuse. Sine 30 is equal to opposite, which is V2N, over the hypotenuse. Opposite siya ng ating angle, di ba? Yung V2N. This is our solution for finding V2N. V2N is equal to 15.84 sine 30 degrees. Therefore, V2N is equal to 7.92 rin meters per second. Same with the value of V1N at point 1. Now, to solve for the value of our V2X, our solution is U cosine 30 degrees and then ano yung adjacent sa kanya. So, ang adjacent sa 30 degree ay itong part na to. Itong part na to. So, that is V prime plus negative V2X. So, bakit negative V2X? Kasi V2X is towards the left. So, sa ating coordinate plane, this is positive Y and this is positive X. Therefore, this is negative X and this is negative Y. So, since ang ating V prime ay papunta sa right, so that is positive V prime plus, so ipapag-add natin ito, negative V2X kasi ang V2X natin is towards the left. So, to solve for V2X, we need to rearrange this equation into V2X, ilipat natin sa kabila, and then ito yung ililipat natin sa kabila. V prime minus U cosine 30 degrees. Therefore, supplying the necessary values, V prime is 10 meters per second minus 15.84 meters per second cosine 30 degrees. Therefore, V2X is equal to negative 3.72 meters per second. So, kapag pinag-add natin yung V prime plus the negative V2X, that is 10 meters per second plus the negative, ano yung negative V2X? The value for V2X is negative 3.72 meters per second. So, this one, magiging positive to kasi negative times negative is positive. Then, magpa-plus siya sa 10. So, that is 13.72 meters per second. So, that is the value of U X. Now, to solve for the angle of V2 with respect to the horizontal line, angle of V2, we can use the tangent function. So tangent theta v2 is equal to opposite, this is opposite v2n, over the adjacent, which is v2x. To solve for theta of velocity 2, we need to transpose yung tangent function sa kabila. v2 is equal to tangent negative 1 v2n over v2x. So that is negative 1. v2n, value nun ay 7.92 meters per second over the v2x, which is negative 3.72 meters per second. That is equal to negative 64.84 degrees. So, bakit negative yung ating angle? Kasi, dito siya galing. Dito siya galing. So, ang negative, ang dinidenote niya, ay galing siya sa left side ng ating point of origin. Kasi di ba pag gumagawa tayo ng angle, kapag galing siya dito, sa right side ng ating point of origin, tinitreat natin siya as positive. So, this is 90 degrees, positive 90 degrees. And then, we can say, or for example, this one is, sabihin na natin na for example lang, that is 110 degrees. Pero kapag negative, ibig sabihin, dito siya manggagaling, sa left side ng ating point of origin. So, ang value niya, ang magnitude niya ay 64.84, and ang direction niya is upwards from the left side of point of origin. Pero still, ang value niya is 64.84 degrees. So, yun lang need tandaan kung bakit siya negative. Kasi it is directed upwards from the left side of the point of origin. So, galing siya dito. Galing siya dito, umakyat siya. So, pag galing dito, tinitreat natin siya as positive. So, positive 90, then positive 180, and then positive 270, then positive 360. Babalik siya sa 0. So, kapag galing dito, titreat natin siya as negative. So, it is negative 64.84. Pero direction niya lang yan yung negative. Ang magnitude niya pa rin ay 64.84. We can also say that this is 64.84 degrees directed upward from left side of origin. So, since meron na tayo ngayong value for the angle of the velocity 2, we can now solve for the velocity 2. So, we can use the sine function. Sine angle of velocity 2 is equal to the opposite, which is v2n, over the hypotenuse, which is your v2. So, rearranging this equation, we will arrive to v2 is equal to v2n over sine theta v2. That is equal to v2n, value nun ay 7.92 meters per second, over sine, gamitin natin yung absolute magnitude ng theta v2, that is 64.84 degrees. Now that is equal to 8.75 meters per second. So for checking, let's try to solve for V2. V2 is equal to the square root of V2x squared plus V2n squared. The square root of V2x squared, that is negative 3.72 meters per second quantity squared, plus yung value ng V2n, which is 7.92 meters per second squared. The value of our V2 is also 8.75 meters per second. So ito na yung value ng V2. And then this is yung direction ng ating V2 in terms ng ating angle of V2. Yan. So meron na tayong answer for this one. Angle of jet of water at inlet. For V2 meron na rin. Angle of V2 meron na. So we need now to calculate for the work. So to calculate for the work, we need to solve for the f of x. So to solve for f of x, ang ating formula ay rho v flow rate v1x minus v2x. But since wala tayong volume flow rate, although alam natin yung density ng water, if you remember, the density of water is equal to mass over the volume. So, kapag itong volume ay minultiply natin sa density times volume, that is equal to mass. If the volume is a flow rate, therefore, ang mass din natin ay flow rate. And since this one is identical to this one, we can say that this density times the volume flow rate is equal to the mass flow rate. Formula natin ngayon ay f of x is equal to mass flow rate times v1x minus v2x. So ito na yung mga values na nahanap natin kanina, v1x and v2x. So ito yung v prime and our v1. So dito, since walang binigay na mass flow rate, we can assume that mass flow rate is equal to 1 kilogram per second. So we can now solve for the f of x. F of x is equal to 1 kilogram per second multiplied to v1x, that is 23.71 meters per second minus yan, then the value of our v2x, which is negative 3.72 meters per second. So f of x is equal to 27.43. This is in Newton. Kasi kilogram times meter over the second. So, pag minultiply mo, magiging squared. Kilogram meter per second squared is equal to Newton. So, yun yung unit ng force. And then, to solve for work, we need to multiply f of x with the horizontal velocity, which is v prime. F of x, 27.43 Newton, multiplied to 10 meters per second. So that is 274.3. So, ito naman, ang unit natin is in watts. Bakit? Kasi Newton times meter per second. So this is Newton meter. This is in joule per second. Joule per second is watts. Ayan. So, na yung sagot for the work done ng fluid doon sa vein. Paano naman pag tinatanong yung efficiency ng jet? Efficiency ng jet. Although wala sa problem, pwede rin kasing itanong ito. So, the efficiency of jet is equal to the work over the kinetic energy in. So, that is work over, ano ba yung kinetic energy? Formula ng kinetic energy, that is 1/2 m flow rate. V, ano yung V na gagamitin natin? Since this is input, that is V1 squared. 1/2 mv squared. So that is 274.3. Lagyan na natin yung Newton meter per second para makita natin yung cancellation of units mamaya. 1/2 m, that is 1 kilogram per second. And then V1 squared, that is 25 meter per second squared. Yan. So ngayon, magkakaroon tayo ng unit analysis. So, Newton meter per second over kilogram per second times meter squared over second squared. So, itong second na to, magka-cancel na agad. And then, magka-cancel na rin yung meter dito. So, magkakaroon ka na lang ng isang meter dito. And then, kilogram meter, meron ka na lang Newton dito sa taas. Then, meron ka na lang kilogram times meter over second squared dito sa baba. So, na-cancel yung isang m dito sa isang m na nasa taas. So, magkakaroon ka na lang ng isang m. So, kilogram meter per second squared, kaya nito is also Newton. Newton over Newton, magka-cancel to. Therefore, this is unitless kasi efficiency. So, ang answer nito ay 0.8778 times 100. That is 87.78%. So, ang efficiency niya ay 87.78%. So, that's it for this problem. Short recap lang sa mga ginawa natin. So, una ay nag-drawing tayo ng illustration. So, binigay na given is 120 degrees. Hinati natin sa gitna, 60 degrees. 60 degrees dito, 30 degrees dito. So, using this illustration, we solved for the angle ng jet of water at inlet. And then, nung na-solve natin, we computed for the V1x and then V1n. After nun, ay sinolve din natin yung relative velocity. Where yung relative velocity natin is also equal sa relative velocity at point 2. So, using that knowledge, we computed for the V2n, which is 7.92 meter per second squared din, kagaya ng V1n. Then, we computed for the V2x. So, bakit negative? Kasi ang V2x natin is towards the left. So, towards the left, siya ay negative. So, nung pinag-add natin, ang x component ng ating relative velocity ay 13.72. So, after makuha yung V2x and V2n, we computed for the angle of our V2. So, using tangent function, and we arrived sa sagot na, sa magnitude na 64.84. So, negative siya kasi galing siya dito, sa left side ng ating point of origin. So, ang absolute magnitude ng ating theta of V2 is 64.84, directed upward from left side of origin. So, ito yung ibig sabihin nun. And then, using the angle, we solved for the V2, which is 8.75. And then, we also used yung ating Pythagorean theorem. So, V2 is equal to the square root of V2x squared plus V2n squared. So, this proves na yung ating velocity at point 2. Absolute velocity at point 2 is 8.75 meters per second. Then after that, we computed for our f of x using the formula, the density, volume flow rate, multiplied to v1x minus v2x. But since wala tayong volume flow rate, dinerive natin yung mass flow rate from the formula for density. Ayan. And then we assumed na ang mass flow rate natin is 1 kg per second kasi walang binigay na mass flow rate. So using that assumption, we computed for the f of x. Then using f of x, we computed for the work, where yung f of x natin ay minultiply natin sa v prime. We arrived at 274.3 watts. Yun yung work ng water sa vein. And then, kapag tinatanong yung efficiency ng jet, that is only the work over the kinetic energy at the input. Work over 1/2 mv1 squared. So, we arrived sa efficiency na 87.78%.